In 1926, an engineer predicted we could transmit text, audio, and images instantly across the globe using an instrument small enough for a vest pocket. Nikola Tesla articulated this vision nearly a century before the first computer was built. When Tesla arrived in the United States in the 1880s, the world was attempting its first major leap into electrification. At the time, Thomas Edison's direct current system was the industry standard. Edison's system ran on direct current, or DC. Because the electricity flowed in a single direction at a fixed voltage, it lost significant strength as it traveled. The energy faded out within a few miles, meaning power stations had to be built on almost every city block. These physical constraints meant electricity was confined to dense urban centers. It was a luxury for the few, rather than a utility that could power a global civilization. Tesla approached this problem not as a manufacturer of gadgets, but as a systems architect. He focused on the underlying physics of how energy and information move through the world. His engineering strategy targeted three specific requirements: a macro network to distribute power across continents, micro machines to do physical labor, and a meta network to share data without wires. Tesla successfully built the first two systems and established the technical framework that eventually enabled the third. To solve the distance problem of the 1880s, Tesla developed the polyphase alternating current AC system. Unlike direct current, alternating current periodically reverses direction. This oscillation allows engineers to use transformers to manipulate the electrical voltage. By stepping the voltage up to extremely high levels, the electricity can be pushed across hundreds of miles of wire with minimal loss. Once it reaches its destination, it is stepped back down to a lower, safer voltage for household use. Tesla proved the scalability of this system at Niagara Falls. His AC generators successfully sent power to Buffalo, New York, demonstrating that a single natural source electrifies an entire region. This breakthrough enabled the construction of modern power grids. It allowed energy to travel from distant plants to the urban centers where it was needed, making the growth of modern cities possible. Even with a power grid in place, the motors of the 1880s were inefficient. They relied on physical brushes that touched spinning parts, creating friction, sparks, and constant mechanical failure. Tesla solved this in 1887 with the induction motor, a machine that operated with absolutely no mechanical contact between its internal electrical parts. By running out-of-phase AC currents through stationary coils in the motor's outer ring, he created a rotating magnetic field. This field reaches across an empty air gap and induces a current in the inner rotor, causing it to spin in tandem. Because nothing touches the spinning rotor, there are no sparks and very little wear. This frictionless design is now the standard for industrial work. It powers everything from heavy factory pumps to the electric motors in modern vehicles. After removing the mechanical contacts from his motors, Tesla turned his attention to removing the physical wires from technology entirely. In 1898, he demonstrated a radio-controlled boat at Madison Square Garden. He steered the vessel across a pool using a wireless transmitter. The audience was so stunned by an object moving without a physical connection that some believed Tesla was using telepathy to control it. This was the first practical demonstration of remote control and wireless communication, the birth of the information network he had envisioned years earlier. Tesla intended to scale this technology with the Wardenclyffe Tower. It was designed to be a hub for global wireless communication and a system for distributing electrical energy through the Earth's resonance. Tesla believed that if he could cause the Earth itself to resonate at the right frequency, people anywhere on the planet could draw power and information from the ground without meters or bills. This vision of free energy was its downfall. When his investor, J.P. Morgan, realized he couldn't put a meter on a wireless system, he withdrew the funding. Tesla died in 1943, with his grandest project unfinished and his name often overshadowed by more commercial inventors. However, that same year, the U.S. Supreme Court restored Tesla's radio patents, recognizing his tuned circuits as the foundational technology for wireless transmission. We live in a world defined by Tesla's architecture. His AC grids provide the power, his induction motors do the work, And the tuned circuits he patented are the direct ancestors of the Wi-Fi and cellular networks that connect our smartphones today.